In this video, we will first find the angle between two vectors, and then we will find the formula, mathematical formula for addition of two vectors. So let's find the angle between two vectors first. Let's say we got two vectors. This is the first vector, we call it vector A, and this is our second vector. Let's call it vector B. Now to find the angle between the vectors, we need to join them tail to tail. So I take the vector B and move it such that the tails of both the vectors are connected now. So what we have done, we are joining the vectors tail to tail. Once we do that, then we can see two angles over here. This is one angle and this is the second angle between the vectors. So we take the smaller of the two angles and we call it theta. So theta is the angle between vectors A and B. Alternatively, we could find the angle between two vectors by another method. This time we join them head to head. So let's draw our vector A again, but this time the head of the vector A will be joining the head of the vector B. Now as you can see, this is vector A, this is also vector A. So both lines are parallel to each other. Then this angle will also be theta. So we could find the angle between the two vectors by joining them head to head. Now let's find the formula for addition of two vectors. So we need to draw the vectors first. This will be our first vector. Let's call it vector A. Then from the tail of vector A, we draw the second vector. Let's call it vector B. Now we draw the parallelogram to find the addition of vectors. So parallel to B vector, we draw a line over here, and parallel to A vector, we draw a line over here. Then the diagonal of this parallelogram would be the sum of the two vectors. So this is, let's call it vector C, which is equal to A vector plus B vector. Now let's elongate the line along vector A, and perpendicular to this line we draw one more line over here. So this angle would be 90 degrees. This angle is the angle between vectors A and B, which is theta. Then this angle over here will also be theta. Now this side of the parallelogram will be equal to this side of the parallelogram, that is, its length will be equal to B. Then if we focus on this triangle over here, it is having one angle equal to 90 degrees. So this is a right angled triangle, and we are taking this angle to be theta. Then this is the base of the right angled triangle, and this is the opposite side of the right angled triangle. Now we know that applying trigonometric relations, what is cos theta equal to? Cos theta is equal to base divided by hypotenuse. In this case our hypotenuse is equal to B. Then if we take the base from here and put it over here, then base will be equal to B cos theta. Similarly, sin theta is equal to opposite side divided by hypotenuse. Our hypotenuse is B. So in this case, the opposite side will be equal to b sine theta. So now we have this height equal to b sine theta, and we have this base length equal to b cos theta. Then this total length will be sum of this length and this length b cos theta. So this total length will be equal to now a plus b cos theta. And if we focus on this triangle over here, this whole triangle, this is the angle 90 degree, this is the hypotenuse of the triangle, this is one side and this is the other side. So if this length is equal to c, then we could say that applying Pythagoras theorem, c square is equal to a plus b cos theta whole square plus b sin theta whole square. This is the side c, this is the side b sin theta, and this is the side a plus b cos theta. So we get this equation. So when we expand this equation, c square will be equal to, we expand this square first, a square plus 2ab cos theta plus b square cos square theta plus, now we square this term, so we get b square sin square theta. So this is our equation. Now this will be equal to a square plus 2ab cos theta plus, from here we take b square common, then we get cos square theta plus sin square theta. Then c square is equal to a square plus 2ab cos theta plus b square times this term over here, sin square theta plus cos square theta, it will be equal to 1. So we get c will be equal to under root of a square plus b square plus 2ab cos theta. This is the mathematical formula for finding the magnitude of resultant of two vectors, that is c vector is equal to a vector plus b vector. Then the magnitude of vector c will be found using this formula over here. Now here I want to tell the students who are watching this video that you just learned one derivation, you learned how to derive this formula, but you will not understand the significance of this formula, you will not remember how to derive this if you don't do it by yourself. So after watching this video, you should sit down, open a notebook, take your pen and try this entire derivation yourself without looking at the video again. If you get stuck somewhere, go through the video once again, then do the derivation again from the beginning until you are able to do it completely by yourself. So we just learned that if we got two vectors, this is vector A, this is vector B, and by drawing the parallelogram we found their resultant. So this is vector A vector plus B vector. Then the magnitude of A vector plus B vector will be equal to root of A square plus B square plus 2AB cos theta, where the angle between A vectors and B vectors is theta. But what if I want to find the magnitude of A vector minus B vector, or magnitude of B vector minus A vector? So let's draw the vectors first. This is A vector and this is b vector. Then the third side will represent the difference of the vectors. If I draw the arrow in this direction, it is a vector minus b vector. If I draw the arrow in this direction, it is b vector minus a vector. So basically, magnitude wise, this b vector minus a vector and a vector minus b vector will be same. This over here is the angle between the vectors theta. Now for this triangle, we draw its height. So this is the height of the triangle. This angle over here is 90 degrees. Now again let's look at this triangle over here. This is a right angle triangle with hypotenuse equal to b. So the base of the triangle will have a length equal to b cos theta, and the height of this triangle will have a length equal to b sin theta. Then first, this whole length is equal to length of vector a, so it is a. Then this part of the length, this part of the line, this length will be equal to a minus b cos theta. Now we observe this triangle. Again, this is a right angle triangle with this side equal to hypotenuse, and the hypotenuse has length modulus of a vector minus b vector, that will be equal to, let's square this side. So the square of the hypotenuse is equal to square of the opposite side, that is b sin theta whole square, plus square of the base of the triangle, that is a minus b cos theta whole square. Then solving this will be equal to, we square this, b square sin square theta plus, we open this bracket, a square plus b square cos square theta minus 2ab cos theta. Now we combine these two terms over here, then we get b square common, sin square theta plus cos square theta plus a square minus 2ab cos theta. So again, the magnitude of a vector minus b vector will now be equal to root of, we take a square, sin square theta plus cos square theta is 1, so we are left with b square, then the last term minus 2ab cos theta. This is the formula for finding magnitude of subtraction of two vectors. So summarizing what we learned, if we got a vector a and a vector b, and by using parallelogram law we find the resultant of the two vectors, then this is a vector plus b vector. Then modulus of a vector plus b vector is equal to under root of a square plus b square plus 2ab cos theta. Similarly, when we are finding vector subtraction, so this is a vector, this is b vector, then this line would be a vector minus b vector, or again this is a vector, this is b vector, then this vector will be b vector minus a vector. Then modulus of a vector minus b vector is equal to modulus of b vector minus a vector is equal to under root of a square plus b square minus 2ab cos theta, where theta is the angle between vectors a and b.